Okay, everybody, we left off with this problem in the last video. You'll see here, just to sort of solidify the idea, look at your end behavior of your graph. I'm falling on the left and rising on the right. Look at your exponent, it's odd. That means one end is up and one end is down. Your leading coefficient is 1 here, that's positive, so it's falling to the left and rising to the right. Okay, so I just wanted to point that out to you. Let's try another one. This one's a little bit different. This is a 4th degree. When we are dealing with 4th degree equations, we're same idea. We're going to set it equal to 0, and we're going to go ahead and solve it. Now, whenever we are solving any sort of equation, right, we want to check for a GCF. In this case, I can actually take out a negative first, right? If I take a negative out, this is really the same as x to the 4th. Excuse me. Sorry, guys. Minus 4x to the 3rd plus 4x squared is equal to 0. And I can take out a GCF of x squared, and that leaves me with x squared minus 4x plus 4 is equal to 0. So that would be x squared times x minus 2 times x minus 2. So here I have x equals 0, x equals 0 because there's 2 of them, x equals 2, and x equals 2. Remember, it's a 4th degree equation, so I should have 4 solutions. Even if I have the same solutions, I still technically have 4. Okay, and let's look at the graph of that. Let me clear this out. I have negative x to the 4th plus 4x to the 3rd minus 4x squared. Okay, let me graph that. And you'll see here what's happening, right? It's the exponent is even, so both sides either go up or down. The end behavior is falling on both sides because that leading coefficient is negative. Okay, so that's what the zeros tell you. They tell you where you're touching the x-axis or where you're crossing the x-axis. And that's where we're going to get into the discussion of multiplicity of zeros. And the idea behind multiplicity of zeros is this. Depending on how many times a zero occurs, tells you what happens at that 0 on your graph. Okay, let me go back here to this one, and let's look at the graph. If you notice, actually, I'm going to do this first. Let's go back here, and let's look at the graph. I'll put this in y2. So let me turn this one off here. And I'll put in y2. We have x to the 3rd plus 3x squared minus x minus 3. And let's graph that one. You'll notice in this one, at each 0, my graph is just crossing the 0 and going to the other side. So you'll see I just cross through at -3, I cross through the x-axis at -1, and I just cross over the x-axis at +1. If you look, each of these roots only shows up one time, right? I only have x to the -3 one time. I only have x equals -3 one time. I only have x equals 1 one time. I only have x equals -1 one time. If you look at this graph, if we go back to the graph, let me turn this one off, and I'll turn this one on, and let me graph that. if you notice with this one, right, I'm not passing over or through the x-axis. I'm touching it and then turning around, right? I'm touching it and then turning around at 0 and at 2. And notice the number of solutions I have. I have 2 solutions there and 2 solutions there that are 2 and 0. And that's where the idea of multiplicity comes in. Okay? If you have an even number of that particular root, so if r is your root and that r value shows up an even number of times, for example, 0 is a root and it's showing up an even number of times, it shows up twice, then your graph is going to touch the x-axis and turn around. That's what happened here. We touch the x-axis at 0 and we turn around. Let me graph that for you so you can see it a little bit better. This is kind of what our graph looks like, right? We're coming up here and we're touching and we turn around, and we're touching and we turn around. That's because of my multiplicity. 0 is a root, but it's a root twice, so it's a root an even number of times. I touch the x-axis and I turn around. Same with 2. 2 is a root and it shows up an even number of times. It shows up twice, so I touch the x-axis at 2 and I turn around. Okay, up here, our graph looked something like this. We're at -3, and our graph did this. We went like this, and then like this, and then something like this. Something that kind of looked like that, okay? And I just cross the x-axis, right, at each of those values because they only occur one time. Each of these roots are occurring an odd number of times. So that's what multiplicity is, okay? So if r is even, so r is your root, so if it shows up an even number of times, if r is an even number of times, meaning if it shows up an even number of times, it doesn't matter if the root itself is odd or even, just the number of times it shows up is odd or even. Excuse me. If it's even, you touch the x-axis, and turn. Touch the x-axis and turn around. If r is an odd number of times, cross the x-axis. And all of these little things, we're talking about zeros, we're talking about end behavior, we're talking about multiplicity. All of those things are going to help us to develop our graphs as we go through the different examples. Okay? So multiplicity. Let me show you what I mean. If you have the function f of x is equal to x plus 1, excuse me, to x minus 3 squared. Okay, I do not need to multiply this out. I don't need to expand it to know that this is this, right? I just have to set each factor equal to 0. This comes out to be x equals -1. And this comes out to be x equals 3/2 and x equals 3/2 because of this 2. And all that means is I would have a multiplicity of 1 for -1 and a multiplicity of 2 for 3/2. Okay? My graph, now you can tell also by looking at this, the end behavior. You don't need to multiply it out. You know that this part here is a second degree, this part here is a first degree, so overall my function would be a third degree polynomial if you were to expand it out. So you know it's either you're going to have one end up and one end down. You also know your leading coefficient is going to be positive. You can tell that just by looking at it, which means I'm falling to the left and rising to the right. I know what my roots are. Here's -1, 1 and 2, so I'm at 3/2. So if I were to just do a very rough sketch of my graph, I know that this is what's going to happen. Okay, I cross the x-axis at -1, because as a multiplicity of 1, I touch the x-axis and turn around at 3/2 because it has a multiplicity of 2. The end behavior I got just by looking at that function. I know it's third degree, and there aren't any, right, neither one of these first two parts of my binomial are negative, which means that my leading coefficient has to be positive. So that's how I know I fall left and I rise to the right. That's pretty much it for now. That should get you through the assignment. We'll pick up again next class, and we'll continue on with the idea of polynomial functions. Have a great day, everybody.